Very good evening all. Welcome to the video lecture series on simple electronic circuit design. In this video, now I am going to take a concept called comparator. So basically, a comparator is an electronic circuit, you all know, which compares two voltages applies to the input, and it can able to produce output either high or low. It will compare the two input voltage applied at its input terminals. You all know that operational amplifier has two terminals. One is inverting terminal and another one is non-inverting terminal. And when we apply the voltage to its two inputs, it will compare the threshold of these two levels, which is greater and which is lesser. And based on the configuration, it will produce the output either it may be high or low, depending on the biasing input. So basically comparators are of two types. One is inverting and non-inverting comparator, but basically these two comparators can be realized within a single configuration based on the design. So what are all the two different types of design, and how we are going to consider a single design, and we are going to realize two forms of the comparator that is the special input in this video. So as per the theoretical concept, these things are already you know. So two input, one is my input voltage input and another one is my reference voltage. These two things will get compared. Which one is greater than another one? Based on that, the output may be either plus V saturation or minus V saturation. Since this is a open loop amplifier connection, there will be no gain concept. So directly the voltage, the operational amplifier will go into saturation mode, that you all know. This is the continuation of the second lecture, that is based inverting and non-inverting terminal, inverting and non-inverting operation of operational amplifier, how they will behave in open loop mode and how it will behave in closed loop mode. These things just the advancement. We are telling this concept the same with the help of a thing called comparator. So this is the input voltage applied here, and based on the things, it is when it is crossing zero, then you just see when it is crossing zero, it is switching between minus V saturation to plus V saturation. But on seeing this graph, you cannot able to understand what actually the processing happening in the electronic circuit. On what basis this is flipping from minus Vsat to plus Vsat, that you cannot able to understand unless you realize the circuit in a. That is why the importance of realization is taught in this course. Whatever course you are studying in a theoretical pattern, try to simulate it using a available simulation tool so that you can realize more than what is the expectation. In the theoretical concept, we can able to see only a graph. When it is crossing zero, it is going on. So minus and plus, you will get a square waveform. That's all. But actually, what is the scenario behind this operation? How you are getting this square waveform? Why this flipping is happening here? These all things will know whenever you are working with a simulation tool. That is why this course is introduced for realizing simple circuits using simulation analysis. Now let us just, this is non-inverting input, but later on we will see in a hands-on. So let us take over this LT Spice tool. Here I have designed two form of configuration. One is my input is directly given to the inverting input of the operational amplifier, and here I am giving it to the non-inverting terminal of the operational amplifier. So here you can observe here the positive terminal is grounded. Here the negative terminal is grounded. So this is your input voltage and this is your reference voltage. So here applied input voltage is 7 volts. So when 7 volt is positive 7 means 7 is greater than, that is greater than the negative. 0 will be the reference voltage. When the voltage applied here is 7 volt means this is minus 7. Okay. So minus 7 means what happened? Which one is greater, it will compare. Either 0 or -7, which is greater. So at that time you will get one negative voltage. Since what is the reference? Negative voltage you are getting as the input voltage here, but voltage here is what? It is 0. So when comparing with the 0, which one is positive, which one is negative? So that we will, if I am telling all these things, means you cannot able to imagine what is happening in the circuit. So that's why we have to realize this circuit using a graphical pattern. If you see the graphical pattern, you can understand. So remember this term, we are applying 7 volt as one of the input and 0 volt as one of the output, one of the another reference voltage. So on comparison, it is going to produce some output that we are going to realize now. I think based on the previous lecture series, you can know how I am designing this circuit. I am using label nets here. So the cross wires are unnecessary, cross wires are avoided. So you can also use number of circuits in a single screen by using label nets. Unnecessary confusion in the wirings will be avoided. So you have to develop your technical skills by making the circuit understandable and understandable to those who are the users of the circuit. So let us run this simulation. So you can see here what is happening, right? So let us think over here. This thing I don't want, so this only, right? I am running now. First I am going to measure input voltage, that is 7 volts. You can see here 7 volt is coming positive and negative. Okay, so it is oscillating between +7 and -7. That is input voltage. Then I am going to see what is the output. You can see a square waveform is coming, right? So what is the meaning of the square waveform? It is starting at -15 volts. Since biasing voltage is 15 here, so it is starting at -15 volts. So what is the meaning? So negative is greater than positive. Negative is greater than positive. So negative has certain potential quantum, but it is grounded. So at that time what happened? Negative, because negative, and this voltage is also negative, negative half cycle. You can see here, this is 0. This is going to the peak voltage and it is crossing here. The crossing point is 0. Once again it is crossing the 0 point. So at that period, what is the level of voltage here? +5 volt. When it is +5 volt means what is the meaning? Actually this and this 0 reference point are compared with each other. That is 0 is lesser and this point is greater. At that time what happened? This negative voltage will be, you will get a -V saturation, since the mode of operation is inverting amplifier. Can you, if this is the concept, means you can able to realize how this is working. So this is operating in between +5 volt and -5 volt, but this is starting from -V saturation. Why it is going to -V saturation means what will be the output from here? That is the meaning. So during positive peak, how the comparison will be happen? That is the thing. So here, instead of seeing it as negative voltage, you see it as a positive voltage. So when positive point is coming here, what happened? This become -5. Okay, so -5 means what happened? This is positive voltage. So positive voltage is applied here. Applied here means this become minus and this become 0. So that means what happened? This will become negative, -V saturation will come. So this concept, if I am telling, means you cannot be able to understand clearly. That's why we are going for this realization. So based on this comparison, the voltage waveform will change from -V saturation to +V saturation whenever it crosses 0. So here it is positive. So positive, at the time it will be negative V saturation. When it is negative, it will be +V saturation. Like that it will be changing. So many of them get confused how it is coming. Why this +V +5 volt is there? Why minus negative? How minus is coming here? That things are confusing. So in order to oversight that, what I am doing is I am going to do one small realization here. So what I am doing is I am going to introduce one more voltage supply. Okay. So then the realization will become quite simple. Everyone can understand, but for more satisfactory realization, you can able to do this in this way. So here what I am doing is I am giving a sine wave. So here 7 volt is there. So first I am giving little bit higher voltage. So 10 volts I am giving here, and the frequency is 50 hertz. Now you can easily understand. That is why I am telling always realize the circuit. Then you can understand in a better manner. Otherwise, you cannot able to realize what is happening. Now you can anyone can tell which potential is higher and which potential is lower. 10 is higher, 7 is lower. So positive is higher than negative. Then what voltage will come here? Positive. Okay, so plus V saturation will come. Even though this is operating in inverting mode, but based on the potential, this comparator will behave either inverting mode or non-inverting. So no need of special separate circuit. Just by varying the potential, you can make one comparator either as inverting comparator or non-inverting comparator. Now anyone can tell positive potential is greater than negative potential. So what will be the output? Plus V saturation. If I make it as 3 here, negative potential is greater than positive potential. So what will be the output? Minus V saturation. That's all. Instead of assuming 0 means plus and minus, you cannot able to realize. But if I give two potentials, you can easily compare which potential is greater. That will be the output. Positive potential is greater means plus V saturation will come. Negative potential is greater means minus V saturation will come. That is the point. Now you can understand. Now I am running the same circuit. You can see here now what is happening. Now I am going to click this. I will close and run once again for better understanding. I will run it. Okay. Now this is input voltage, no change. What is our expectation? Plus V saturation, right? So see here, whenever it is crossing 0, it is going low. At that time, what happened? Negative potential will become greater than positive. So at that time, what happened? This flipping will happen. Okay. So whenever a positive potential has majority, plus V saturation will come. Whenever negative potential has holding the majority, minus V saturation will come. This is the ultimate thing. Okay, sir, if I am changing this potential to lesser voltage, instead of 10, I am giving 3. Okay, then what happened? Now you can tell. Minus minus is greater than positive. Minus potential is greater than minus quantum is greater than plus quantum. So what will be the output? Initially, it will start from minus V saturation since it is major. After that, what happened? This 3 will become majority, so it will change. So instead of starting from plus V saturation, now it will compare which is greater in magnitude, that minus V saturation will come as a output. That you can realize here. Okay, let us check here. Okay, and now I am running the circuit. You can realize now this is input, no change. What is the expectation? Minus V saturation, right? Coming minus V saturation to plus V saturation. So either the circuit is grounded or given with reference potential. The flipping is only between minus V saturation to plus V saturation. Just this is only a comparison only, which potential is greater, that's all. But output will depends on, output is dependent on where is this 15 volt from where it is coming. We are giving 7 and 3 only, but from where this 15 is coming means biasing voltage is 15. If you give biasing voltage as 10, then this voltage will reduce to 10 volts. That also we will see here. Once I will Once it will be realized means you can. So instead of 15, I am changing this to 10. Okay. And instead of 15, I am changing this to 10. So what is the expected? Instead of 15 volt saturation point, it will get saturated at 10 volts itself. That is the main. So I am running this circuit once again. So what happened? I am clicking here. You can see here +7 to -7, no problem. If I click here means what is the expectation? Instead of 15, the voltage is got saturated at 10 volts. So you can now understand from where this 10 volts is coming. 10 volt is nothing but what? Biasing voltage. So operational amplifier goes into saturation based on the biasing voltage. So if you give two reference voltage, one is reference and another one is input, means the realization will become very easy. So here what happened? +5 volt is greater than 0. So initially what will be the answer? Plus V saturation. When it is going negative, automatically the flipping will happen. Here initially I have given 0. But I am giving here 7 volts. So 7 volts have majority at negative terminal. So initially what will be the voltage? Minus V saturation. That is, after realizing this, you can realize any circuit. Now you can tell easily which polarity is having majority. That will be my output. That output will be what? By my biasing point. Whatever voltage I am giving in the bias, that will be my the saturation point of my operational amplifier. Okay, so this is the thing. Now if I want to realize the circuit means you can realize, but what happened? This will be 5 volts. So I can rerun this. I will close and rerun. That will be better for understanding. So if I click here means +5 to -5. What is the expectation now? You can tell. +5 volt is connected to positive. So positive is major. So what will be the output? Plus V saturation. So what will be the plus V saturation point is what? 10 volts. Since biasing voltage is 10. Okay. So we will click here. It will come. Right. So this is how the comparator is work. Whenever the voltage is positive for non-inverting input, the output will also be at plus V saturation. When it is crossing 0, the comparator changes its state and reflects the negative point. So whenever it is crossing 0, you will get the corresponding pulses. So if you count the pulses here, 1, 2, 3, 4 means how many number of times a signal is crossing 0, that can be counted. So this circuit is also referred as zero crossing detector. How many times a signal is crossing 0, that we can detect very easily. Like that. So here also you can do the same process and you can estimate how a non-inverting comparator is going to work. Okay, so now instead of starting from plus V saturation, when it is positive means it will start at minus V saturation. So since if I switch this point from plus to minus means minus will have the majority first. So minus V saturation will be the output. So whenever the signal is positive, the majority V saturation will be it will take the point as minus V. That is the point which is connected here, that is plus 5 volt, is greater than 0. Now it become minus 5 volt, it will be greater than 0. So minus 5 volt greater than 0 means what will be the output? Minus V saturation. That will come. That will be flipped. So earlier I showed that waveform. Now it is replaced with what? It is replaced with voltage potential. That's why. So I am just telling in terms of words. For better understanding, you can also realize. So what I can do is, for better realization, I will delete this voltage and directly connect this point to ground so that you can able to realize. Right? Fine. Now you can, if I run this means what you will get, you already know. Meanwhile, I will touch here. Okay. Red color is the inverting comparator. Now it is changing from -7 to +7. What is the expectation now? Expectation is minus, it should start from minus V saturation. right? So I am clicking here. So you can see it is the green color line. It is starting from minus V saturation. At 0, it is going to plus V saturation. Once again, it is deducting 0, minus V saturation, plus V saturation. So without using this ground potential also, by means of providing a potential reference, you can make one circuit either to work in the inverting mode or non-inverting mode. That is possible. Okay. So like this, you have to realize and you have to understand any circuit in a deep manner. Then only in interview or in examination point of view, no need to study. Just this concept will help you to write everything. So no need to by God or memorize any circuit diagram. Automatically it will come to your mind since you are realizing that. This realizing will never be forgotten throughout your lifetime. Once you study this comparator means that's all. It is permanently registered. If you just study the book and realize only in theoretical manner means within a short span it will be, you will forget how the V side, what is V side, everything will be forgotten. So my sincere advice is when you are studying one circuit in earlier days, uh, there is no simulation facility. Now this is online. LT Spice is a online simulation tool available for everyone in a free manner. This is a open source tool. Anyone can download. So you can download it into your laptop, take some good circuits from your book, and realize everything and think that whether the theoretical what you are studying and practically what you are getting is realizable or not. Then only your design journey will be a perfect journey. With that things, I hope this is understandable. So with that things, I will close this session and good luck to you all. We will meet you in the second video lecture, upcoming video lecture sessions. Thank you all.